Embedded OSs. Now, this is more controversial. It's flavor, I don't care what it is. Anytime I find a device that has a full-blown embedded OS on it, it's the attack surface that it gets expanded, because more than likely, because of the complexity of even embedded OSs, you're going to forget to turn something off. You're going to forget to disable some core feature that, the guys that did your original load never even thought about. SMTP when it's not used, So to me, an embedded OS is nothing but a big attack surface. And there's lots of tools that have been built around automated penetration testing and attacks against these OSs for the most part. So, I don't even have to be real good at it. All I have to know is what scripts I need to kick off, and, I'm as good at script kiddie as anybody. Updates, maintenance, talk about updating your firmware. And depending on how you built out your network, that's going to be expensive, folks. I've heard from customers already that are using third-party network providers and going, man, that bill is a whole lot more than what we expected. And, that's just collecting the money. That's just collecting the billing information so they can bill their customer. And when they start pushing out 12, 16, 32K updates, I don't care if you're paying by the packet or by the minute, that's going to be expensive. You're looking at hundreds of thousands of dollars to do a meter upgrade. So, these become, very critical. Another thing that I find, and unfortunately some of y'all will run into this, hopefully not, but, we look at lifespans of these devices and, ideally we'd like to put it in once and it'll last forever. The reality of it is the old mechanical units that we've had in the field forever and have survived forever, doing quite well, mind you, is going to be a completely different thing than an electronic meter that has memory in it. Folks, memory wears out. It has a limited number of cycles that it can be set and reset before it dies. We've seen this already, and you're going to see it more. And the sad part about it is you'll see 2-3 meters fail, and you'll pull them out of the field, and you'll do your diagnostics, and you'll send it to the vendor, and the vendor's going to go, oh, no, it's a memory problem. Now, some of them have enough space where they can move that to a different location and get some more life out of those meters, but a lot of them are not going to. They're not going to have the space, so they're going to run up into the physical properties of the silicon in those devices. Another thing that, this is such a new industry y'all haven't run into yet, but I've dealt with this for years and years, is obsolescence. How many components in your meter, in your backhaul system, are going to be available 5 years from now? Can you even buy those devices anymore? And if you can't, that's a redesign. If you can no longer source a key component, processors, Pentiums, they're, every couple of weeks there's a new Pentium version. Same thing with most of the silicon providers that I deal with. That chip that you built your meter around is not necessarily going to be there tomorrow, and it probably will not be there near as long as you would hope that would be. So, there's lots of uncomplicated things that will really reach up and bite you hard. Some of the other things that I've literally found in devices is some of the processors. We think of, infinite number of read writes to these things, but the code space where the firmware resides on a lot of these processors can be updated 5 times. So you have 5 upgrades before that meter's toast. So, there's a whole lot more in looking at these devices than looking at the security. I often get from my customers, well, that's not security. Well, one of the things about security CIA, availability, well, if it's not available, it's a security issue in my book. So, that's what I use to kind of try to communicate to my customers that, security is not everything in here, but you also need to look at these other things because these are things that will unexpectedly reach up and bite you.
So the question you're talking about, some of these electronics, I guess, are almost consumable in some fashion. But I guess along those lines, so my question was, some of these devices look almost consumable in some fashion. So many times that they can be used before they're
so many life cycles.
So many life cycles. But then what about like things like batteries or super caps and things like that we're seeing in components
Well,
too?
yeah, that's things. Batteries have been probably the biggest factor to longevity of most devices that I've run into. They either have a battery memory backup soldered to the board, or it's installed in such a way that the device has to be replaced. And I don't know about you, but I've been dealing with batteries for a lot of years, and I've seen very few cell phone batteries last more than a couple of years. And you've got a customer or vendor saying that this battery is going to last 10 years. I have a problem with that.
You've got data. If you're interested.
Yeah. My problem is, though, too, is, okay, what was the environmental test of that data?
It's the full temperature test range, -40 to +85.
Good.
Yeah, there are solutions.
And battery technology is changing dramatically. The batteries are getting much, much better. But, this is something to look at in your RFP process. Is a battery field replaceable? Batteries are batteries, and it's one of those necessary evils at this point in time. A lot of utilities have the concept that we're going to repair these devices in the field, and I'm going, hang on. I get these things in a lab, and I have trouble getting into them and getting them apart and getting them back together, and I don't have to worry about it working when I send it back. So, the reality of how much field maintenance is really going to occur is debatable. One of the things that will eliminate that is a soldered-in battery. I see a lot of devices that are very well done. You unplug that battery and the other battery goes in. Simple. As long as that period between each time you have to visit that device is long enough that it's cost effective for you. My thing is you need to be visiting these devices on a regular basis, just open them up, see what somebody's done anything to them. And you really have to spend a few minutes because I can do things that look like they're supposed to be there. Same thing with the credit card guys, they put the little thing on your ATM machine, you go in and swipe your card and they swiped it too, but they make it look really nice. I do the same thing.
Great. Rob,
Yeah.
Any questions?
Any questions? Yes.
So, you had mentioned potting, and I'm not strictly familiar with that term. What I've heard is that on some of these Xboxes, the new version of Xboxes are Lucite. I mean, they're a Lucite cube. Is that similar to what you're talking about?
Yeah, a potting compound is nothing more than it's typically a plastic polymer liquid form that pours into a device and sets up to a rubber. There's different, potting compounds are formulated completely different. I've found most of them that are easily dissolvable with different solvents. I found few that were not dissolvable and readily available solvents, and everything's possible given enough time, money, and right resources. So I always have to gauge things with a dose of reality. Are the solvents readily available? Do I have to have government clearance to get this solvent? Things like that. I've run into potting compounds that I could not find any readily available solvents to attack it. Temperatures were elevated enough that they were close enough to the soldering temperature that in the process of trying to remove it, you're more than likely going to remove a couple of devices in the process. You know, my goal when I go after something is I want a working device. I learn a whole lot more about you from a little device that's sitting there ticking along doing its deal than a dead device. You know, I'll eventually get it from the dead device, but it's a whole lot harder for me and it costs me a lot more money. So, you know, I want to catch that device in operational mode because I can tell what it's doing, and, you know, without having to crack encryption and all that kind of stuff. If I have a working device, then it's really easy to listen to my communications buses and see the passwords and see the encryption keys going across there. You know, as it goes by, it's easy to catch. It's a whole lot harder to dig it out of the system. You know, talking about secure development of your firmware and software. Do this, you know, people that have access to it. Get a raw dump of the memory of your devices. Run it through a hex converter so it makes some intelligent sense to it. And do nothing but scroll through your software. One of the things that really kind of jumps out and will kind of hit you right between the eyes is logon, password, memory address for password. So, you know, anything that is human readable, if something on the screen comes up that says enter password or enter logon, more than likely when I yank that memory map out of your device and scroll through it with a simple text editor, I'm going to see your logon sequence, and normally the next bit in that logon sequence is the memory address of the key for that, and it normally says that it's in external memory and it's X934. So what do? Is I find the chip on the board and I go to that memory address. Guess what? There's your key. So, you know, there's some things that you can do that you don't have to be that super intelligent. You don't have to be the ace #1 crypto cracker in the world to really put a hurting on a lot of these devices just by looking at them.
I'm going to pretend to be really naive for a second and say, are there communication channels between, say, yourself or somebody that does what you do and the vendor community, such that somebody would say, you know what, I found this thing about 50 times in the last month. Y'all might think about making just a couple of changes here to really modify what's happening.
One of the things is, you know, I'm kind of leery when I speak because I have to be very careful of what I say, how I describe it. Do I give too much information? Because I will be sued. I will get a call in the middle of the night raising hell. It's happened. You know, I've been there, done that. Typically, the way it has to work, especially with the way the engagements are set up now, is I communicate my findings to my customer, which is typically the utility. The utility decides what they want to tell the vendor. I would like that to be completely transparent, but understanding the way things are, that's the way it is. You know, you get a good customer, and that really is, security is a primary concern, is we do see benefits. You know, the things that we do find do get passed to the vendors, and the next version that we see oftentimes will have that issue fixed. You know, it's a simple thing that typically makes my job much easier. When the engineers design your boards, they label things. You know, there's test points and voltages and things like that. You know, my game is an information game. I'm looking for every little tidbit of information about your device that I can find. And TX and RX on test point 1 and 2 are dead giveaways, folks. You know, I don't care who you are or how dumb you are. It's a no-brainer. You know, test points have to be there, but they don't need to say 12 volts. They don't need to say transmit and receive. You know, be cautious of what the boards say, because believe me, somebody eventually is going to look at it, and there's a wealth of information that's often silk screened right on the surface of these things. Yes?
My name is Mark Witteman. I work for a security test lab. I was triggered by your statement that you know little about cryptography. And I completely agree with you that attackers are always looking for the low-hanging fruit, and there's many of opportunities to get in a device. So my question to you is, expecting that vendors will improve their equipment, and at a certain point that all that low-hanging fruit that you're using today is no longer available, when do you think that attackers need cryptographic knowledge to do, search for cryptographic implementation flaws to attack these systems?
It comes down to this, and one of the things I normally always state in any engagement is penetration testing is a team sport in my book. You know, I have my specialties. It's the things that interest me. It's the things that I've been doing for 20 years. It's you know, the RF communications. I've been a ham for years. You know, it's the things that are exciting to me. Slade, on the other hand, is our crypto guy. He's the one that likes the web interfaces. So it's having a team that's well balanced, that knows different aspects of it, and that's the things that they get off on. To be good at something like this, you have to really enjoy it. And the ones that are really good at the crypto, that's what they live and breathe for. You know, I'm going to find that expertise and use it. You know, mine is embedded systems, writing code. I know how the systems are developed. I know how they're glued together. So it's very easy for me to attack what I know and go after those, you know, the low-hanging fruit, which unfortunately, until things make some fundamental changes, which I really don't see happening in the near future, most of that low-hanging fruit will continue to be there forever.
Okay, that's clear. Thank you.
Any other questions?